All right, let's get right into it. Today, we're doing a deep dive from one microbiologist to another into one of the heavy hitters we see in the lab, Klebsiella pneumoniae. Now, we all know this organism, but the way it's evolving is forcing us to rethink our entire approach.
And this quote just hits the nail on the head, doesn't it? It perfectly frames the problem we're up against. We're seeing this perfect storm where extreme virulence is merging with broad-spectrum drug resistance, and that combination is why Klebsiella pneumonia is keeping so many of us up at night.
So everything we're about to cover has been pulled together using a Gemini deep search, which allowed us to synthesize a ton of information. And if you want to get into the weeds and check out the primary literature for yourself, the full list of sources is right there in the linked notebook document. Okay, so here's our game plan. We're going to follow a classic bench-to-bedside path. We'll start with the bug itself, then move to how we nail the ID in the lab, what it does to patients, the huge challenge of resistance, and finally, how we can stop it from spreading. First things first, let's really break down what makes Klebsiella pneumonia such a tough opponent. We'll look at where it fits in the grand scheme of things and dig into this whole perfect storm idea. Okay, this is absolutely crucial to understand. We're really dealing with two different beasts. You've got your classic hospital-based Klebsiella pneumonia, the one we're used to seeing in immunocompromised patients. But then you have this other monster, the hypervirulent pathotype, that can cause these crazy metastatic infections in young, healthy people. And the terrifying part? The line between these two is blurring. All right, let's head over to the lab bench. How do we actually identify Klebsiella pneumoniae? We're going to walk through the whole process, from the old-school phenotypic methods right up to the gold standard of genomics. You know the drill. Our diagnostic workflow follows a pretty logical path. We start with the basics. What does it look like under the microscope and on the plate? And then we move on to the more definitive stuff, the biochemical tests and molecular methods that give us the full story. So looking down the scope, you see a classic gram-negative rod. But the real telltale sign, the thing that makes you think Klebsiella, is that big, beautiful polysaccharide capsule. It doesn't take up the stain, so it looks like this clear halo around the cell. It's one of your first big clues. Now on the plate, you have to look for this, the hypermucoviscous phenotype. The colonies look incredibly shiny, wet, and gooey. This is a huge visual tip-off that you might be dealing with a hypervirulent strain. And the way we confirm it is just classic micro, the string test. You touch the colony with a loop, and if it stretches out like a string of mozzarella for more than 5 millimeters, that's a positive test. And here's its biochemical fingerprint, the pattern that gives us our definitive ID. That negative indole test is so important for telling it apart from Klebsiella oxytoca. Oh, and pay attention to its intrinsic resistance to ampicillin. If your system reports an ampicillin-susceptible Klebsiella pneumoniae, that should set off alarm bells. Something's not right. But let's be honest. Today, whole genome sequencing is the real game changer. It gives us the ultimate resolution. With one test, we can track an outbreak down to the single nucleotide level, get the sequence type, and see every single resistance and virulence gene the bug is carrying. It's truly the new standard for public health. Okay, so we've got our organism ID'd. Now let's connect those lab results back to the real world, back to the patient. What kind of damage can Klebsiella pneumoniae actually do? This bug is incredibly versatile in the worst possible way. It causes that classic severe necrotizing pneumonia with the current jelly sputum we all learned about. It's a major cause of complicated UTIs. But what's really terrifying is its association with pyogenic liver abscess. That's a hallmark of the hypervirulent strains that can spread all over the body. And this, of course, brings us to the biggest challenge of all, antimicrobial resistance. So let's talk about how we fight back, using standardized testing and evidence-based treatment guidelines. Sticking to standardized breakpoints, like these from UCAST, is absolutely non-negotiable. This is the framework that lets us all speak the same language to reliably call an isolate susceptible or resistant, which is obviously essential for making the right call for the patient. Now, if we look at local guidelines, like these from the Dutch SWAB, you can see the logic for empiric therapy. You see a clear escalation pathway, right? Starting with cephalosporins, moving up to piperacillin tazobactam, and then bringing out the big guns, the carbapenems, when you're in a hospital setting with a high risk for resistance.
For those confirmed ESBL producers, the extended spectrum beta-lactamase producers, the international consensus is pretty clear. Carbapenems are your go-to for serious systemic infections. And this last point is so important. Remember the Merino trial. It showed that for ESBL bacteremia, piperacillin-tazobactam just wasn't as good as meropenem. So we really need to avoid it in those critical cases.
Now, when you're dealing with carbapenem-resistant Klebsiella pneumoniae, you have to know what kind of resistance mechanism you're up against. Newer drugs like ceftazidime-avibactam work great for KPC and OXA48 producers. But the MBLs, the metallo-beta-lactamases, those are the toughest nuts to crack. They often need these complex combination therapies or brand new agents just to have a chance. And of course, treating kids is a whole different ballgame. Everything is meticulously dosed by weight, and when you're managing these highly resistant bugs, you absolutely have to get an infectious diseases specialist involved. It's also good to know that things like extended infusions of meropenem are often necessary just to make sure we're hitting our therapeutic targets in these smaller patients. Okay, last but certainly not least, let's talk about containment. Because with these multi-drug-resistant organisms, preventing them from spreading is every single bit as important as treating them. The only strategy that has ever been proven to work is this bundled approach. It's not one thing, it's everything, all at once, all the time. It's the relentless combination of hand hygiene, contact precautions, cleaning the environment, actively looking for carriers, and smart antimicrobial stewardship. That's how you win. So that leaves us with a really important question to take back to our own labs. How can we, as microbiologists, innovate and streamline our processes to make active surveillance for these bugs faster, smarter, and more effective? And that wraps up our look at the incredible challenge that is Klebsiella pneumonia. We really want to keep this conversation going, so please subscribe for more explainers just like this one, and more importantly, share your own experiences and questions down in the comments. Thanks so much for watching.